This is one example of related rates problem on your textbook for number 19, but I'm going to change this with the circumference instead of area. So I'll put it as a circumference, but the idea is same. Okay, a rock thrown into a still pond causes a circular ripple, of course, if the radius of the ripple is increasing by 2 feet per second. So try to identify those kind of things. dr over dt is increasing by 2 feet per second. Now, how fast is the, let's say, the circumference changing when the radius is 10 feet? So it's asking about dc over dt. Okay, yeah. Let's put the circumference formula. So you'll have a c equal with 2 times with pi times with r, right? Or sorry, I got mixed. 2 times with pi times with the r, and we can put it like this: dc over dt equal with 2 pi. Remember, 2 pi is a constant, times with dr over dt. So in that case, we already get our answer. dc over dt will be 2 pi times with 2. Yeah, so that will be 4 pi feet over second. This is how the circumference will change over time. Now, this might sound easy for you. Let's try another one, or let's compare it with the area. Okay, so I'll put it over here, the area. The area is pi times with r square. So in that case, that will be dA over dt equal with pi times with dr square over dt. So dA over dt equal with pi times with dr square over dr times with dr over dt. You may wonder why I keep using this one. I insist you to put it like this, yeah, because I want you to be familiar with this all the time. I have reasons not to use it, but for sake of your learning, I use it, so you'll understand. Okay, so I insist that you use it like this, the chain rule, and then that will be sorry, pi times with 2r times with dr over dt. Dr over dt is 2 feet per second, and then the r we also know, pi times with 2 times with 10 times with 2, so that will be 40 pi feet square per second. That's what it means, that when the ripple is increasing by 2 feet per second, when the radius is 10 feet, then the area will increase by 40 pi feet square per second. Okay, this might not sound interesting. Let's try another one. Let's say we have this kind of situations. There's a car, the red car, moving with 60 mph. So let's say that this is d of x, or d of a. Let's put it a. d of a over dt. The moving car is 60 mph, and then we also have the green car, which is b. Okay, let's put it db over dt is equal with 30 mph. So the value over here is very important. Now it goes into these directions for the green car, and then for the red car it also heading the same directions toward here. And the red car having a distance from the intersection is 0.8 miles while the green car 0.6 miles. Now what we want to know is the rate of change of their distance over time. Okay, so they have a distance, you have 0.8 miles, you have 0.6 miles. It means that at this particular time they are separated by, let's try to take a look at this, since this is the intersections and it's perpendicular, then we can just put it 0.6 square plus with 0.8 square equal with s square, and we'll get s equal with square root of 0.6 square plus with 0.8 square. We'll get s equal with 1 mile. Okay, so they are separated by 1 mile distance. Now 1 mile, let me put it 1 mile. Okay, now the question is, what is their distance over time? What is their distance over time? We can then put it like this: a square, it means the distance of the A from the intersection, plus with b square, the distance from car B to the intersections, equal with the s square, which is the distance between these two cars. Okay, and then let's put the derivative, which is the rate of change, dA square over dt plus with dB square over dt equal with ds square over dt. You might find that there are many symbols over here, but don't be afraid. Why you should be afraid? Okay, dA square over dA times with dA over dt plus with dB square over dB times with dB over dt. This is using chain rule, equal with ds square over ds times with ds over dt. Okay, I insist that you are using this one. 2a times with dA over dt plus with 2b times with dB over dt equal with 2s times with ds over dt, and we are looking for ds over dt again. Yeah, so let's put what we already know. I'll put a. The a, it means that the distance, that will be 0.8 times the dA over dt, that will be 60 mph. Yeah, and then plus with 2b. So I forgot to put 2 over here. 2 times with b. B is the distance of the green car, so 0.6 times with dB over dt is 30 equal with 2 times with 1. S is a 1 mile over here from our calculations, equal with ds over dt, the one that we're looking for, times with ds over dt. Okay, so then we'll get, this will be 96, yeah, and then added with 36 equal with 2 ds over dt, and 96 plus with 36, that will be 2 over here, and then 132 divided by 2, so we'll get 66 feet per, sorry, not feet again, I get wrong, 66 mph. Yeah, so that's the rate. Okay, this one is taken actually from Khan Academy problem. Yeah, so you can check Khan Academy problem. They have a lot of good stuff with the related rate problems, include the owl. Yeah, you should check that one. Okay, so this is what I can give. Thank you.